Hi, Mrs. Jacobs here, physics teacher at Naperville North, and I'm here to do a short tutorial on how to analyze a velocity versus time graph. And this tutorial is going to focus on the qualitative part of analyzing this graph, not the quantitative where we're actually using these exact numbers. That will be in a second tutorial video. So today we're going to look at what does this velocity versus time graph mean in terms of the motion of the object? And how do I draw a position versus time graph that matches this? So let's start off by understanding that on the y-axis, this means velocity. So when I see this +3, this is +3 meters per second. So at the beginning of the motion for segment A, the object, even though this is a flat line, on a flat line on a velocity graph means the object is moving. It's moving at 3 meters per second in the positive direction. So if I'm going to describe the motion of the object, I would say for segment A, it's moving in the positive direction at 3 meters per second. Okay. Segment B. Segment B is now below the x-axis in the negative region. So if it's below the x-axis, I know the object turned around and now it's moving in the negative direction. Turned around and moves in the negative direction. And it's actually faster than segment A. Okay, the number is more negative, but it is -5 meters per second covers 5 meters every 1 second. +3 meters per second covers 3 meters for every 1 second. So this is actually the faster segment. The negative just means it was moving to the left. Okay, so if I think about the motion of the object, let's say here's where I start. For segment A, it's moving to the right at 3 meters per second. Then it turns around and it's moving faster to the left at -5 meters per second. During segment C, it is on the x-axis, okay? That means that it has no velocity, 0 meters per second. Another way to say that is it's at rest. It's not moving. That's the only way to show at rest on a velocity graph is on the x-axis. And in terms of the motion map, you would just have dots stacked up on top of each other to show that it has position, but the position is not moving right to left. It's just staying the same. Now, how do I draw a position versus time graph that matches that story? A position versus time graph has meters on the y-axis. It's important to know that the velocity graph tells you how fast you're moving, but it doesn't tell you where the object starts, okay? You're not given the starting position. So you can choose your own starting position. Okay, I'll just go ahead and choose 0 meters. But if you started the graph up here, that would also be fine. Let's say this is segment A. It's moving in a positive direction, okay? But then segment B is moving negative, and it's moving negative faster. So on my position graph, that needs to show up as a steeper slope. That was 5 seconds of motion. B has to be steeper, and B needs to cover more meters in the same 5 seconds of time. So I'm going to have it actually go below 0 meters. This is still qualitative. We're not going to put numbers over here on the y-axis, but I do need to show that B is a steeper slope than A. And then segment C is at rest. So segment C on the position graph needs to be a flat line. So this is the correct qualitative position graph that matches the story of this velocity graph. Again, if you wanted to start up here and do segment A, segment B steep, and segment C flat. That would also be acceptable, okay? What matters here is the shape, not the actual starting position and ending position.